Today we're going to talk about hypothesis tests for one-sample proportions. Here are the assumptions and corresponding conditions you must check before creating a confidence interval for a proportion. The independence assumption. The data values are assumed to be independent from each other. We check three conditions to decide whether the independence is reasonable. Is there a reason to believe that the data values somehow affect each other? This condition depends on your knowledge of the situation. You can't check it with data. Were the data sampled at random or generated from a properly randomized experiment? Proper randomization can help ensure independence. Is the sample size no more than 10% of the population size? The sample size assumption. The sample needs to be large enough for us to be able to use the central limit theorem. We must expect at least 10 successes and at least 10 failures. The conditions for the one proportion z-test are the same for the one proportion z-interval. We test the hypothesis. The null is p equals p sub 0 using the statistic z equals p hat minus p sub 0 divided by the standard deviation of p hat, where the standard deviation of p hat is equal to the square root of p sub 0 q sub 0 over n. When the conditions are met and the null hypothesis is true, this statistic follows the standard normal model, so we can use that model to obtain a p-value. Let's take an example. State University wants to increase its retention rate of 4% for graduating students from the previous year. After implementing several new programs during the last 2 years, the university reevaluated its retention rate using a random sample of 352 students and found the retention rate at 5%. Test an appropriate hypothesis and state your conclusion. Step 1, we need to develop our hypothesis. So our population parameter is p, and it equals the population proportion retention rate. Our null is p equals 0.04, with our alternative being p is greater than 0.04. Step number 2, check the assumptions and conditions. We have a simple random sample. It's stated. We can safely assume that our population size is greater than 10 times 352, and we're going to find out if NP and NQ are both greater than or equal to 10. Now, since we know what P is equal to, we're going to use P rather than P hat. So NP is equal to 352 times 0.04, which is 14.08, and NQ is equal to 352 times 0.96, which is 337.92, and they are both greater than or equal to 10. Step 3, we're going to calculate our test. So z is equal to p hat minus p sub 0 over the square root of p sub 0 q sub 0 over n. Our p hat is 0.05. That is our sample proportion. P sub 0 is our population proportion, which is 0.04. The standard deviation is the square root of 0.04 times 0.96 divided by 352. Solving this, we get 0.957. So we draw our normal model. Since our alternative is a greater than, we're going to shade everything to the right of our z-value. Finding the probability using normal CDF, we get 0.169. Since our p-value is a conditional probability, we write it as the probability that p hat equals 0.05 given that p equals 0.04 is equal to 0.169. Our final step is our conclusion. We have to identify an alpha or significance level. Since the problem doesn't state one, we're going to use 0.05. Since our p-value is greater than alpha, we fail to reject the population proportion retention rate for graduating students is 4%. The university should not continue with the new programs. Our second example. Do 8% of Dallas citizens commute to work? A survey of commuting by car was done on a random sample of 1,000 citizens and found car commuting to be 10%. Test an appropriate hypothesis and state your conclusion. So step 1, our hypothesis. Our population parameter is P, which is the population proportion of Dallas citizens that commute by car. Our null is P equals 0.08, and our alternative is P does not equal 0.08. The reason it does not equal to is in the problem, it doesn't state whether it went up or down or what they think it might have done. So we just want to know if it's different than 8%. Step 2. Check our conditions and assumptions. A simple random sample is stated. Population size is greater than 10 times 1,000. An NP, which equals 80, and NQ, which equals 920, are both greater than or equal to 10. Step 3 is to calculate the test. Z equals our sample proportion of 0.10 minus our population proportion of 0.08 divided by the square root of 0.08 times 0.92 divided by 1,000, and we get 2.331. So drawing our normal model, what we're going to do is we're going to shade both sides. Since we have 2.331, what we're going to do is find the probability from 2.331 to infinity. That probability is 0.0099. Now, since this is a two-tailed test because of our alternative, we're going to double this number. So the probability that p hat equals 0.10, given that p equals 0.08, is equal to 0.0198. Our final step is our conclusion. A significance level was not stated, so we'll use 0.05. So our conclusion is, since the p-value is less than alpha, we reject that the population proportion of Dallas citizens that commute to work is 8%.